Okay, so in the last video, I translated a longer argument. We didn't test it for validity, even though it was valid, because it just had too many sentence letters. We'll learn how to deal with those kind of sentences in this week's lectures via a method called truth trees. This is another argument. It's slightly shorter, and I'll symbolize this. Yeah, symbolize it and test it for validity using truth tables. So this is an invalid argument for antinatalism that I just kind of made up. Antinatalism is the view that it's morally impermissible to have children. It's, in this, for now, we care about the logic in this class, not so much the content of the words. So let's get to symbolizing. First, we want to identify the conclusion, which is, we can see here, we have a therefore. Therefore is a nice conclusion marker, and it marks that this sentence here, therefore it is morally impermissible to have children. That is the conclusion of this argument. And then I'll number the premises. That's premise 1, the first sentence. And we have second sentence here, it's premise 2. And then the third sentence, that's premise 3. So we have 3 premises and a conclusion. So when we want to symbolize, let's get to symbolizing. Symbolizing the first sentence, well, first, let's note that we have a sentence letter for it is morally permissible to have children. This says it is morally impermissible to have children. We have a sentence letter for the human species should die out, which is what this says. And so this, we have the if then. That's a loud marker that the main connective of the sentence is a conditional. And then we have the im part, impermissible, which means that there's probably a negation involved here somewhere. So let's start with symbolizing the antecedent of this conditional. It is morally impermissible to have children. Well, we have C, it is morally permissible to have children. So not C is it's impermissible to have children. Then it's conditional. So we have an arrow. If it is morally impermissible to have children, then the human species should die out. So we have D for the human species should die out. Then, yes, that's premise 1. For premise 2, we have, however, the human species should die out if and only if there is no other way to save the oceans. We have an if and only if here. That's a connective that hopefully you are getting more familiar with. We also have this little however here. But however, it's not really doing anything logical. It's just kind of connecting this sentence with this sentence, trying to like smoothen out the transition. And in logic, we don't care about smooth transitions. We just care about the logic. And so that doesn't matter here. We can ignore the however. And so for the sentence letters, we have the human species should die out. That's D. Then we have there is no other way to save the oceans. Well, for O, we have there is another way to save the oceans. So there'll be some kind of negation there as well. So putting this together, we have D, the human species should die out. If and only if and only if is a double-headed arrow. So we have the human species should die out if and only if there is not another way to save the oceans. Our sentence letter just says that there is a way to save the oceans, so there's no other way to save the oceans, it's not O. All right. Premise 3, there is no other way to save the oceans. Nice and easy, we just did this in the above premise. We have not O. And then the conclusion. Therefore, it is morally impermissible to have children. This little 3-dot symbol means therefore. So it is morally impermissible to have children. That's not C. So C is it is morally permissible to have children. So it's morally impermissible is not C. And this is our translation, or our symbolization, sorry. And to construct a truth table for it, I'll just move over to a whiteboard. For our letters, we have C, D, and O. The things in our argument are, we have not C implies D. As one premise, we have D if and only if not O. For another premise, we have not O as another premise, and we have not C as the conclusion. This is the conclusion, and these are the premises. Now, in order to test whether an argument is valid, we want to try and see if there is any row in the truth table that makes the premises true and the conclusion false. Now, in this case, the question itself said that the argument's invalid. So what we want to do is to identify the row in the truth table that makes the premises true and the conclusion false. And that row will be a counterexample to the claim that the argument is valid. So I'll just set up the truth table real quick. Okay, so to do a truth table for this premise, first we start from the innermost and move to the outermost connectives. So the innermost here is this not. So to evaluate not C, we just flip the values of C. So write 0, 0, 0, 0, 1, 1, 1, 1. That gets us not C. To evaluate this whole connective, we compare the values from not C with those of D. And this whole connective will be true whenever not C is false or whenever D is true. The only time it will be false is if not C is true and D is false. So here in the first line, we have, well, for the first 4 lines, not C is false. So that makes this whole thing true. And then for the next 4 rows, well, for row 5, we have true and true. We have true and true. Then we have not C is true and D is false in these last 2 rows. So that means that this whole thing is false. Now, moving on to the next next premise, we start with not O, since that's the innermost connective. We just flip the values of O. So this is 0, 1, 0, 1, 0, 1, 0, 1. And then to evaluate the whole biconditional, we compare the values of not O with those of D. And the biconditional will be true if they have the same truth value and false otherwise. So the first row, they have different truth values. Second row, they're the same. Third row, they're the same. Different, different, same, same, different. Let me just check I got that right. Okay, yes, I didn't get it wrong. Nice. Okay. So those are the first 2 premises. The third one is nice and easy. We already did here, not O. So we can just copy the values from there. And then the conclusion, not C, we just flip the values from C. We already did it over here. So we can just copy that again. Okay, and now, so we fill everything out. We want to hunt for a row that makes the premises true and the conclusion false. So in this one, that doesn't work because, oh, sorry. First row is not that case because we have false premises. In the second row, well, we have all true premises, right? We have true, true here, oh, sorry. True here, true here, true here, and then false here. So this is a row that's a counterexample to the claim that the argument is valid. it shows that the argument's invalid. And let's just see if there are any others. In this, we have a false premise. This, nope, nope. This one, all the premises are true, but the conclusion is also true, so that's fine. Sorry, this was in this row. That's fine. And this row, we have false premises. In this row, we have false premises. So all the other rows are fine in the sense that they're not counterexamples because they either have a false premise or or they have all true premises and a true conclusion. This row, row 2, is the only one that gives us a counterexample. The counterexample is when C is true, D is true, and O is false. Let me just rewrite that a bit. O is false. So that's what we want from this truth table. And so what this counterexample means is that whenever C is true, D is true, and O is false, that means that this whole argument is invalid. That's how you translate basic sentence and use the truth table to find a counterexample for an invalid argument. Note that if the argument were valid, we wouldn't have a counterexample. There would be no rows in which all the premises are true and the conclusion is false. It's only for invalid arguments that we can extract these kind of counterexamples. All right, so that's tutorials done for this week. Next week, we will be doing, or in tutorials, we'll be going over truth trees, which will be introduced in lectures this week. Yeah, so we'll still have online office hours and we'll evaluate your assignments soon, or once we get them later this week. Have fun in your homes.